Good morning, Earth Science. Welcome back. Feels like it's been a month since I've seen you. We finished up volcanoes. We're still talking about plate tectonics and what happens where the plates touch. We get things like volcanoes, but another thing we get are earthquakes. An earthquake is when the ground shakes, when it moves. And just like volcanoes, these happen where the plates are broken, where the pieces come together. This is the ring of fire around the Pacific Ocean. And you can see all the big earthquakes that occur in the trenches where it gets pushed down through subduction. So they don't just get volcanoes, they get earthquakes too. When a volcano erupts, it usually has earthquakes with it. They happen together. This line over here is not as bright. It's the mid-Atlantic ridge where the ocean plates are tearing apart. But it also gets small earthquakes. When that tearing happens, when they slide, that causes the ground to move and shake. Now, sometimes in the movies, they show huge cracks in the ground and people fall into it. That's not really how an earthquake usually works. That would be pretty extreme. But we can get actual cracks that show up in the ground. The problem with earthquakes, for the most part, is buildings, especially taller buildings, because when they shake, they can fall down. Where you can see even houses, which are not that tall, can be very dangerous in an earthquake. If we zoom in on the United States, you see that we get earthquakes all through the country, but most of them are on the plate boundary, where the Pacific plate and the North American plate come together. That's where most earthquakes in the United States happen. Now we look for a reason why, what actually causes the earth to move or shake or crack. And scientists talk about something called the elastic, which means stretchy, like a rubber band, and rebound. Like in basketball, when you get the ball back, that's a rebound. It comes back to where it started. It stretches, and then it snaps, and then it goes back. But notice when it comes back, everything moved a little bit. It's not quite the way it was before. So there's four main steps that happen. The first step is the plates stop moving. They lock together. And that is because of friction. Deep in the ground, when the plates push against each other, it gets hot and it gets stuck. And that's a problem because when it gets stuck, it can't move anymore and it starts to bend or stretch. We all know what happens if you stretch something too far, eventually it breaks. And that's what an earthquake is. In step two, it stretches, and then the energy has to go somewhere. And the last step is everything moves. Here you can see some more examples. The plate stops moving, it stretches and bends, and then it snaps. You can see it can move a couple inches, maybe even feet at a time, depending on how big the earthquake is. Speaking of how big the earthquake is, that's called magnitude. Magnitude, how big, or we say the strength, how strong is the earthquake? And in the news, they use something called the Richter scale. The Richter scale talks about earthquakes that are a 6, a 7, a 9. And look at this scale, it goes from very small to very big. And it does it fast. Well, here, I like this on the left-hand side. You can see a 1, we don't even feel. Only machines can feel an earthquake that's a 1. A 2 might make the lights swing in your house. A 3 might slosh around some water on a shelf or a cup on a table. But it's not until you get to about a 4 that humans actually feel the ground move. And you would actually be able to hear it, feel it shake a little bit. When it's a 5, you're going to feel like the house is moving. You're going to hear it creak. You're going to have things fall off the shelf or get knocked over in a 5. But as long as you're out in the open, in your house even, you don't have to worry about it falling down. By the time you get to a 6, you have to start being concerned. That's when it's really going to shake and rumble and everything's going to fall down. And an upper 6, you can even have buildings start to weaken and fall. Anything over a 6 is going to be pretty bad. There's a good chance people are going to get hurt. And we have had some earthquakes that are 8s and 9s, and I'll show you some of those next week. And those, of course, are the ones that kill people. We measure all of this by the waves, the energy that's in the quake. And we measure the waves using what is called a seismograph. That should be easy. A graph, right, shows the ups and downs of the energy. And so here's how a seismograph works. The earth shakes, but we have a heavy weight with a marker on it. And so it stays in place. This is called inertia. And as the paper goes through, it marks how big the shaking was. Seismograph, how big the earthquake, the magnitude. Okay, that's where we want to stop today. So I want you to know a couple of key vocabulary words. Elastic, stretchy, rebound, snaps, magnitude, how big the earthquake is, Richter scale, and of course, seismograph, which measures the shaking. That's your first set of vocab. All right, we will do more earthquake stuff tomorrow. I think you're going to like this chapter. It's interesting. Have a good day, Zoom. Bye-bye. Stay warm.